Representation of relief or elevation on a topographical sheet using contours. So today we will be studying about contours and how they represent the various physical features or the landforms. There are several methods which are used to depict physical features on a topo sheet. Using contours is the most common method of showing relief or elevation in the topo sheets. So what are contours? We have already read that the contours lines connect all points having same height above mean sea level. So whenever you write the definition of contours, you have to write that they are imaginary lines and they connect the points having same height above mean sea level. That is also very important to write. So these are the key words which a definition should definitely have. So these contours are the imaginary lines which join the places having same height. So look at the line or the value of 600. The brown line which is there written near 600, that means all the places which are falling on that line that have the height of 600 meters. And because it is 600 meters is not much from this mean sea level, therefore you will find that this line is the largest compared to the 1200 value. So next is the 800 line which is smaller than 600. So this means that as we go higher and higher the altitude, the length of the contour goes on decreasing. And as we come towards the lower height, towards the sea level, then the contour length goes on decreasing, and hence the value also increases with height and the value decreases with depression. Now on a topo sheet, there are several such lines with specific numbers that indicate height of all the places connected by these lines. This will give you a better view. Can you see 0.542 in this survey sheet, around which there are contours marked with brown color. So you have to look at the contours and the numbers and identify the landform. So how it will be identified, we will do that when we make the cross section of these contours, which we will be doing it later. But before that, we'll be discussing other important features of contours. Now this is contour which is represented on a sheet, on a map. Look at the numbers. They are in the center has the highest number, and the outwards it goes on decreasing. The lines becomes shorter, smaller in the center, but the numbers are increasing in both the contours. And this kind of contour, it represents the first one is a conical hill and the other one is a plateau or a highland with a slightly flat summit. So the point to be noted here is that the numbers are decreasing from center towards the outer lines. There are two important terms. One is vertical interval and second is horizontal equivalent. Vertical interval means the difference in height between two adjacent contour lines, which is also known as contour interval. Generally in your survey sheet, the contour interval is 20 meters. You can see here this diagram. Here the contours are made with a difference of 20 meters only. 60, 80, 100, 120 and 140. So this is known, the difference between any two adjacent contours, they are known as vertical interval. Now the next one is horizontal equivalent. Here you can see that the distance between the turns or two adjacent contours, they are been marked here as HE. So when you come to the line 500 meters, the HE is not very small or not very long. Therefore, the slope over here will be not very steep, not very gentle. So the gradient is quite okay. So it is climbable. Then we come to 400 meters height, where HE becomes very small and therefore there is a sharp bend, and here we can say that the slope is steep. Then we come to 300 meters. So there you can see that the difference between two turns of the contours or horizontal distance between both of them have become quite large, and therefore the land also becomes gentle, has a gentle slope. Then we come to the next one, 200 meters. Here again it is large, so it is not very steep, not very gentle. And then the last one, at 100 meters, it is quite small. The HE is quite small, therefore the slope is becoming steep. So this is about the vertical interval and horizontal equivalent. Now we begin with the characteristic features of contour lines. Contour lines are drawn at fixed vertical intervals, for example 20 meters. These intervals on the map will not change. They depend on the scale of the map and the range of elevation in the area of the map. So in your map survey sheet, it is always written contour interval is 20 meters. Whichever sheet is made for India, it has contour interval of 20 meters each. The contour lines do not intersect each other. You can see that none of them are intersecting each other. The contour lines do not intersect one another. They could meet, they can touch each other, but never cross one another. And this is the cross section made of a cliff. You can see a cliff besides a sea. Now look at the height of 400, 300 and 200. These three lines are joining each other. That means there has been a sudden drop in the height due to the erosional work of the river or wind or waves, because it is at the seashore. So because of which the rock has broken and there is a sudden drop. So here the contours are meeting each other and depicting that it is a cliff. Now the contour index. Every fifth line is drawn thick to show the contour index. This is shown where the land is very steep and it is very difficult to mark each and every contour. So in that case, the geographers, they take help of the index contour, which is marked very dark brown color, which is broader also compared to the other contours, and they indicate the contour index. In your survey sheet, it will look like this. You can see spot height 542 in the right side of the survey sheet, around which the contours are made in brown color. So these are known as the contour index, the dark ones. 500 line, then 400 and then 200. In between there is 300 also. So the lines in between them, that means 100 lines must be there, and therefore it is difficult for us to mark each and every contours. So in this case we take help of the index contours. Then you can see that some of the contours are very closely spaced and some of them are far off spaced. So this indicates that the closeness of contours indicates steepness of the land, and far apart contours indicates gentle slope of the land. This was the characteristic features of the contours. Now we will be doing some examples. I'll show you that how it is made on the map or the topographical map. Suppose this is a conical hill. This will be made in your map like this. Why 600 is at the top in the center? Because it is depicting the highest most area. So the 100 is over here and 600 will be somewhere here. So the contours also goes on decreasing in length as we go towards the interior of it. Opposite thing can happen when it is a valley. I will show you the contour cross section of valley also. So this is a conical hill. Then this is an escarpment. That means one side is steep and the other side is a gentle slope. One side has steep slope and the other side has gentle slope, like this. So this is known as an escarpment, and in the contours when we make, it will show like this. One side, see, the contours are far apart, so the slope is gentle, and the contours are very close to each other, then the slope is very steep. Next is a valley. This will be represented as this. Now here you will see the change in the number. In the center, the number is less compared to the outermost number. So that means it is a depression, and therefore in the center it has less height, and at the side it has higher height. So that is why a valley will have a lower number in the center and higher numbers outwards. This, because it is a flat tableland, so therefore there are no contours in the center, and hence see in the cross section also it is made like a flat table top, and then the sides are steep, having the height between 600 to 900 meters. So this is a plateau. So roughly the contours are made like this. We will have to learn to make the cross section, which I will be teaching you after this